Okay, kids, let's go for the next skill. Okay, so I am gonna find the inverse of a transformation, no? O sea, so what type of transformations are we studying? We're studying like the transformations that are like a times a vector plus a vector, no? O sea, and remember, whenever I have this, that it could be like a reflection, a rotation, a dilation, and this is a translation. O sea, this type of transformations, the transformations that are either reflections, rotations, dilations, followed by a translation, this is what we called affine transformations because they are very fine, no? Like transformations. O sea, this is like the general formula. What we're studying the geometry behind like affine transformations. So, uh, what we're gonna do in this skill is trying to find the inverse. O sea, like if I give you a point, o sea, yeah, like the inverse of this function. Before we go, o sea, this is a hard skill. But before we go to that hard skill, they say that I always say that everything is the hardest thing. I am so sorry. So this is a hard skill, honestly. But before, we need to talk about this. The inverse of a matrix. We have spoken about like this formula before, like how to find the inverse of a matrix. O sea, in the formula booklet, if I give you, let me say, I'm gonna work with this matrix. The matrix, I don't know, like 6, 7, 7, 8. Okay. So for example, what is the determinant of this matrix? It's gonna be a gigantic number. No, it's gonna be 6 times 8 minus 7 times 7. 6 times 8 is 48. 48 minus 49. This is actually, whoa, this is actually a reflection. Whoa, whoa, whoa. Isn't it? Yeah. Okay. And so that means that using this formula, that means that the inverse of this matrix is going to be 1 over negative 1 times 8, 6, minus 7, minus 7. O sea, when you want to find the inverse, what do? You flip these two numbers and you change the sign to these two numbers. That is how you do it with the formula from the formula booklet. Before we move on, let me teach you something super cool that Anastasia taught me today in class, that it's how to do it with the reduced row echelon form, o sea, how to do it with the matrix, with the calculator, sorry. So just let me show you how to do it. So we're gonna do this. In the calculator, I am gonna put this matrix. I am gonna put the matrix 6, 7, 7, 8. And next to it, I am gonna put this matrix. O sea, like all, o sea, I'm gonna put this set of numbers, no? All in the same matrix. So here is my original matrix, and next to it, I am putting a 1, 0, 0, 1. It's the 1, 0, 0, 1. This is what we called the identity matrix. This is the identity matrix. Okay, so I always put this identity matrix here in this row, in the reduced row echelon form. O sea, let me show you what is going to happen. So I grab my calculator. I create a matrix. So I'm going to go to this function called reduced row echelon form, number 5. Inside, I am going to put a matrix, no? What matrix am I going to put? I am going to put this matrix. O sea, this matrix that is, how many columns, how many rows does it have? It has 2 rows, 4 columns. 2 rows, 4 columns. And so I write it down. That is 6, 7, 1, 0, 7, 8, 0, 1. Okay, look what is the output. Let me write it down and I will, okay, so my output is 1, 0, 0, 1, negative 8, 7, 7, negative 6. O sea, if you look at the output, here in my first like block, I have the identity matrix. And next I have the inverse matrix. So this means that A inverse is the same as we got using the formula. Negative 8, 7, 7, negative 6. So I got the same thing. No, I got the same thing because this negative multiplies each one. No? And so it is negative 8, negative 7, negative 7, negative 6. And I think that this is a very cool way of finding inverses of matrices. The logic behind why does this work? O sea, what does it mean for the identity matrix to be in the right side and then for it to be in the, sorry, for the identity matrix to be in the left side and then for it to be in the right side? O sea, and why would this be the inverse? No, what is happening? What is happening behind this built-in function is a very deep concept that has to do with something called the Gauss-Jordan elimination process, that has to do with pivots, that has to do with elementary matrices operation. O sea, the logic behind this function is a thing that you will learn in a linear algebra course. O sea, in a linear algebra course, you actually will learn how to do this by hand. But I think that it is very cool that you're learning how to do it with your calculator because I think that it's a super cool operation. Okay, having said that, I'm gonna keep using the built-in function, no? So, this is a hard skill. Be prepared. So, right now, I have just spoken about how to find the inverse of a matrix, either with the formula or with the calculator, okay? Now, I want to find the inverse of this function, where A is this matrix and B is this vector. So, what do we do when we want to find the inverse? O sea, like I have T of X equals to A of X plus B. And so, like, this X is like in volts, no? O sea, and this B is in volts as well, because these are vectors, no? I could also write T of XY equals to A times XY plus, I don't know, like B1, B2, no? O sea, these two things are equivalent because when I write it like in volts, the IB is going to write it in volts. Volts means vector, no? Okay, so I want to find the inverse of this function. What do we do when we find the inverse? Do you remember what are the steps? To find the inverse, first of all, instead of writing f of x or t of x in this case, I'm going to write y. Y is going to be equal to ax plus b. Then, because I want to find the inverse, I'm going to switch them, no? So that is x equals ay plus b. Okay, I want to solve for y. I want to isolate y. So the first step is a very natural step, which is doing x minus b equals to ay. Okay, now the most natural thing would be to divide by a, no? O sea, I want to do divide by a, and so the a's cancels down. But we cannot divide by a. So instead of dividing by a, o sea, here, as I can't divide by a, I am gonna multiply by the inverse of a. Whoa, Mr. Quechua. O sea, as I cannot divide, the only way in which I can move this one to this side is by multiplying by its inverse. So, and what does multiplying by the inverse mean? Means because I can FOIL, you know, I can distribute. So that means that I'm going to write it down and I'm going to flip it. Y equals A inverse of X minus A inverse of B. Okay, so the thing that I want to say is this, and the last step is that we put t to the minus 1 x, ¿no? O sea, you have two options. You have two options. You can either memorize this process, which I find fantastic, or you can memorize this formula. I know you're just gonna memorize the formula, but it comes from a beautiful place. O sea, this is the inverse function, no? This is the formula for inverse functions, no? Inverse, they have a name, affine transformations. O sea, let me do this and let me do it in an example. So, o sea, I am giving the matrix 2, 1, 1, 1. So let us calculate the inverse of that matrix. So to calculate the inverse of that matrix, I need to go to menu, matrix and vector, reduce row echelon form. I need to create a matrix. I need to, I need to create a matrix, 2 rows, 4 columns. And so it would be 2, 1, 2, 1, 1. O sea, 2, 1, 1, 1. That is my original matrix. And in my other block, I need to put the identity matrix, 1, 0, 0, 1. And so that means that my inverse matrix is 1, negative 1, negative 1, 2. So what is A inverse? A inverse is 1, negative 1, negative 1, 2. Okay. And now we need to use the, so, and I will just plug it in here. Look, so my inverse transformation is the same as 1, negative 1, negative 1, 2 times x. This is a vector. Plus 1, negative 1, negative 1, 2 times the vector b, and vector b is 3, negative 2. Okay, so there is one more thing that I could do so that this look nicer, no? O sea, I can do this multiplication. So I just need to do the multiplication, and again I go to matrix, create a matrix, a 2 by 2 matrix that is 1, negative 1, negative 1, 2 times menu, matrix, create matrix, 1 row, 2 rows, 1 column, 3, no, 3, negative 2, so this is 5, o sea, so this would, o sea, my final answer would be the matrix 1, negative 1, negative 1, 2 times x plus 5, negative 7, no? O sea, 5 minus 7. And this would be my final answer. Okay, let me, o sea, because I am using this formula, no? Let me do one more example. So, first of all, we need to find the inverse matrix. The inverse matrix of 3, negative 1, 2, 1. So, how do we find the inverse matrix? I go to menu, matrix, reduce row echelon form. I want to create a matrix. And this type of matrix is 2 rows, 4 columns. So this is 3, negative 1, 1, 2, 1, 0, 0, 1. One block is my matrix, the other block is my identity matrix. Then the identity matrix block flips. So I have 1/5, 1/5, 2/5. O sea, my inverse matrix would be 1/5, 1/5, negative 2/5, 3/5. Which looks like a rotation, no? Then, to find the inverse, I just use the formula that you already know by memory. So the inverse of a transformation T, it is A inverse times X plus A inverse times B. So, what is A inverse times B? O sea, so it would be T 1/5, 1/5, negative 2/5, 3/5, xy plus, and what is the result of doing, o sea, a ver, let us go menu, matrix, create a matrix, a 2 by 2 matrix, that is 1/5, 1/5, 3/5, negative 2/5. Ay, qué bobo. Times menu, matrix, create a matrix, 2 rows, 1 column, a negative 4, 5, and so 1/5 and 23/5. So here I just have to put 1/5 and and 23/5. So this is my inverse. It doesn't look that hard. It is not that intimidating, no? Woo, math!